This is how our solar system looks from outer space. To us, standing on the Earth, the sun, the moon, the planets, and the stars appear to be moving on the surface of an enormous sphere. Astronomers call it the celestial sphere. The sun moves in a circle along this celestial sphere. This circle is called the sun's ecliptic. The fact that the sun, the moon, and the planets appear to move along a narrow strip about this ecliptic tells us that they all lie more or less in the same plane. In other words, the solar system is like a flat disk. To appreciate the importance of these ancient discoveries, we need to know modern astronomy a little. The Earth is a sphere that rotates like a spinning top round its axis every 24 hours. This axis is inclined at an angle of 23.5 degrees to its ecliptic. This is responsible for the seasons. For half the year, the northern hemisphere is tilted towards the sun. And for the other half, it is the southern hemisphere which is tilted towards the sun. To observers on Earth, this appears as an annual north-south movement of the sun. The northward movement is called uttarayana and the southward movement dakshinayana. These journeys keep recurring with great regularity. The farthest points to the north and the south, the turning points, are called ayyananta or solstices. They occur on 21st June, called Grishmakalin Ayyananta or the summer solstice, and 23rd December, called Shitakalin Ayyananta or the winter solstice. Midway between these solstices, day and night become of equal duration everywhere on Earth, and the sun would rise exactly in the east. These were called Vishuva or equinoxes. They occur on 21st March, called Mahavishuva or the vernal equinox, and 22nd September, called Sharada Vishuva or Jala Vishuva, the autumnal equinox. Reference to the solstices can be found in the Aitareya Brahmana. There is a passage which shows that the sun was found to remain stationary for 21 days near the summer solstice. These 21 days were divided into 10 days of Uttarayan and 10 days of Dakshinayan, with the 11th day as the solstice. How could they be so certain that the sun actually remained stationary for exactly 21 days? They probably used a gnomon, or sanku in Sanskrit, a measured vertical pole stuck in the ground in an open horizontal plane. The shadow cast by the pole would turn from west to east during the day, varying in length as it moved and reaching a minimum at noon. Marking the positions on the ground in the mornings and afternoons when the shadows were of equal length, they took a string and stretched it so that its endpoints would touch the endpoints of a pair of equal shadows and then mark its middle point. The line joining that middle point to the base of the pole would bisect the angle and thus give the north-south direction. This is how the ancient astronomers determined the east, west, north, and south. This was essential for monitoring the uttarayana, dakshinayana, and the seasons. Since antiquity, Indian society has relied more on the moon than the sun for its calendar. A very important concept in the Indian calendar is that of the tithi, or lunar day. All religious and social functions and festivals of the Hindus are determined by the tithi. The lunar cycle begins with the crescent moon, and this crescent phase lasts till it culminates in the full moon. It's the waxing phase, lasting typically for about 15 days. It's called Shukla Paksha or Sudha Paksha, the bright phase. Then the moon enters the waning phase until it disappears from the sky by lining up with the sun. It is the waning phase, and it also lasts for about 15 days and is called the Krishna Paksha or the dark phase. The 15 days of Shukla Paksha and the 15 days of Krishna Paksha make one lunar month. During the Shukla Paksha, the angular distance between the moon and the sun changes from 0 degree to 180 degrees. That is, from conjunction to disjunction. During the Krishna Paksha, the angular separation between the moon and the sun changes from 180 degrees back to 0 degrees. If we divide 180 degrees into 15 equal parts, the duration of a paksha, then each part becomes 12 degrees. Thus, each 12-degree portion of angular distance between the moon and the sun, as it appears from the earth, is the tithi. Tithis in Shukla Paksha begin with Prathama, Dvitiya, etc. till we reach Purnima, the full moon. Similarly, for the Krishna Paksha, the Tithis again begin with Prathama, Dvitiya, etc. till we arrive at the Amavasya. These tithis have special names depending on the time of the year. For example, Ram Navami is the Navami or 9th lunar day of Shukla Paksha of the lunar month Chaitra or Chaitra Shukla Navami. Incidentally, according to the Islamic calendar, the lunar year is strictly based on 12 lunar months or 354 days, and the seasons are totally ignored. That is why the holy month of Ramadan occurs approximately 11 to 12 days earlier than in the preceding solar year and passes through all the seasons. Coming back to the Hindu calendar, the month was named after the nakshatra in which the full moon was found. For example, Phalguni Paurnamasi is that full moon when the moon gets full near the nakshatra Uttar Phalguni or Beta Leonis. Similarly with Chaitra Paurnamasi, when the moon gets full near the nakshatra Chitra or Alpha Virginis. Later, the word Paurnamasi was dropped and the months became simply Phalgun, Chaitra, etc. There being 27 nakshatras but only 12 months, the following 12 nakshatras at approximately equal intervals were finally adopted and are still in use. According to the Vedanga Jyotisha, the correct definition of the seasons is based on the cardinal points. Starting with the vernal equinox on 21st March. However, the majority of calendar makers in India do not follow this. Instead, they follow a system called Nirayana, which is mixed up with astrology. They refuse to take account of the precession of the equinoxes. Due to the fact that the Earth is not a perfectly spherical body, but has a bulge around the equator, the gravitational pulls of the sun and the moon and the other planets on it produces a certain wobble of its spin axis. The wobble is very, very slow, and it takes 26,000 years to complete one revolution. As the spin axis changes slowly, the vernal equinox also shifts west along the ecliptic very slowly, so as to complete one full revolution in 26,000 years. Therefore, 13,000 years from now, summer will be winter and winter summer. Amazingly, this minute movement was recorded in the Vedic texts and was known as Ayana Masa. But this knowledge was never systematized in India. Some major astronomical texts of later periods do not even mention it. The first astronomer to understand its importance was Hipparchus of Greece, as we will see later. The important lesson here is that as a result of this precession, the vernal equinox now occurs 23 days earlier than 1500 years ago. So today, when we celebrate Holi to welcome spring, following traditional calendars, we are actually missing it by 23 days. Like the spring festival or Holi, festivals and fairs are held throughout the year in India based on important astronomical events like the solstices and equinoxes and the onset of the seasons. These events are not mere esoteric curiosities in the distant sky. They are intimately connected to us. They regulate not only our physical life, the festivals and fairs organized around them act as drivers of economic growth and sustenance and of cultural bonding. That is why they have survived for thousands of years, providing cultural continuity. They are a fusion of the cosmic order and the human entity. The celebration of a deep harmony between man and nature. It is truly amazing how such complex astronomical observations were made and systematized so early in the history of human civilization. What made that possible? Well, it has been conjectured that the emergence of the first cities on earth might have had a lot to do with that.